Section 11.4, applications. Okay, let's just kind of look at the applications we're going to be looking at here using linear equations. Some of the things you might see on your Hawks is supply and demand in business, velocity and acceleration in engineering, money, interest in investments, and mixture in physics and chemistry. Don't let any of this worry you. This is going to be linear equations. We'll work them out, and then we'll kind of work our way through some of these word problems. That's going to be the hardest thing in this, and just to be honest, guys, word problems, to get better at them, that just takes practice, okay? So I kind of added this in that you can save, you can print, just when looking at word problems, just kind of remember that you need to go through this, what they call the cubes. I did this whenever I was teaching in the lower grades. I still use it today because even at my level now, it's hard to decipher word problems, okay? So let's just be intentional with our reading. Let's be very careful. Just pay attention to what it's asking. Go through here, underline the question. What am I being asked to solve? Make sure, especially in Hawks, some of the word problems, you may need to have to click the tutor button. There's nothing wrong with that. I know that whenever I was here at the JC, I clicked that tutor button all the time. So let's do just a quick example, then we'll just jump into the Hawks. Let's do the quintessential algebra, question. The one that when people start talking about algebra, they always this seems to be the one, except I think it involves trains usually. Two buses leave a bus station, traveling in opposite directions. Okay, as you can see, one leaves at noon, and the second leaves at 1 p.m. The first one travels at an average speed of 55 miles per hour. The second one at an average speed of 59 miles per hour. At what times will the buses be 226 miles apart? Okay. Going back in time, we know that distance is basically rate multiplied by time, and that's going to equal our distance. Okay, which is how they got these right here. We're going to give each one of these a different variable. Notice they have the 55x and the 59y. Well, right here we can have bus 1, and its rate, how fast is it moving, is 55 miles an hour. Multiplied by what? By x, that time. Well, what's its distance? Well, its distance is 55 multiplied by x. Well, bus 2 is going 59 miles per hour. Multiply it by y. I'll put little dots here to help out. And its distance will be 59y. So let's set up a linear equation that we can use to find out how long it's going to take for these buses to be 226 miles apart. Kind of scroll down here just a little bit. Setting up our linear equation, one is going to have to involve just the time. So we're going to have x is going to equal, well, y plus 1. Remember this y one? It's ahead by 1 hour. Okay? Then we're going to have another one here of 55x plus 59y is going to equal 226. This is saying, when are both these buses right here, when are they going to be 226 miles apart? Now, look what we have here. We already have x equals y plus 1. So we can take this y plus 1 here and substitute it into that x position. So we are going to be doing, I believe it was, 11.2? We're going to be doing substitution. So let's just be intentional with what we're going to do. We're going to take this 55, and instead of putting x, I'm going to come in here, let's change the color here so that we can kind of see it a little bit better, and put y plus 1. Okay, then I have plus 59y equals 226. Let's take this 55 and let's distribute it inside the parenthesis. That's going to give us 55y plus 55 plus 59y equals 226. Now, add like terms, which is going to be here and here. Okay, and then we can also, after we get done adding like terms, we can take this 55 and subtract it from both sides. When we do that, let me scroll down just a little bit here, we're going to get 55 plus 59. Use your calculator. Don't be freaking out about that. Use your calculator as much as possible. 114y. And once we subtract over here, we're going to get 171. Notice we have a multiplication, so we're going to divide that off both sides, and we're going to get y equals 1.5. Now take this and back substitute. Back substitute into what? Back substitute it back into our original equation. Well, we now have a y, so let's figure out what x is. X equals, well, instead of the y, we'll put in this 1.5 plus 1, and we're going to get x equals 2.5. So the answer to this question is, if you have to do this in HOX, they're just going to ask for 2.5 because that's how long it's going to take. But the actual answer is, how long, at what time will the buses be 226 miles apart? Well, 2.5 hours is how long it's going to take. So there's a quick little example. We kind of worked through it intentionally, but we're very careful. We'll do a few more HOX and just kind of keep getting those green bars.